probably just strict, simple combinations with really no frills to them. One of the things that we look at when we're dealing with combinations, and then later on, whether it's probably not tomorrow, next week sometime, we're going to talk about what's called the binomial theorem. What happens with what's called the binomial theorem is that it's going to allow us to take a binomial, and instead of foiling it out 8 times, there's a shortcut. And it's awesome.
Calculator.
No. So we'll talk about how this works, and it's really, really nice. But the more important part is to talk about what are called combinations. Combinations are going to be when you are picking values or picking things from a stack where order does not matter. It comes into play a lot more often when you're dealing with cards. Because if I shuffle a deck of cards and I deal out 5 cards, does the order in which they're dealt have any bearing upon anything at all?
Yes.
Yeah.
It really doesn't. Okay.
How would you know?
So what happens is, guys, what happens is that we need to actually acquaint ourselves with a deck of cards. Because I've come to the rationalization, that, or realization, I always say the wrong version of that, is that a lot of you guys, except for Matt, I'm not that great at shuffling. So a lot of you guys probably don't know what's in a deck of cards. Now, first of all, how many cards are in a deck of cards?
52.
52. We don't worry about jokers, okay? We don't worry about them. So you have 52 cards. How many suits are there? 4. 4 of them. You'll have
Diamonds.
Hearts.
Spades.
Diamonds.
Hearts.
Diamonds.
spades.
Diamonds.
Clubs.
Oh, there we go. All right.
I thought this was going to be a magic trick.
I know.
I was like, wow.
We're not there yet. Hold your applause till the end.
Okay.
So when you have a deck of cards, and this is gonna be a lot of things you have to try and keep up. Some of you guys know this. There's 52 cards. There's 4 suits. You have diamonds, hearts,
Amazing.
There. Oh, there it is.
Definitely.
Wow.
Ace for effort. That's what you should grade on math test, by the way.
It's tree.
It's broccoli florets. Anyway, of the 4 suits, how many cards are in each of the suits?
13.
There's 13 in each of them.
Blackout.
No, I already said
Oh, I missed that too badly. There are 13 in each suit. The numbers go 2 through 10. And then you have Jack, Queen, King, and an ace. The ace would bite, which depends on the game. 8, when you're playing blackjack, aces are 1 or 11, depending on how you want to play. Now, the only ones that are technically called face cards are the ones that have faces. Jack, Queen, and King. And ace is not. So, when you start thinking about just the total possible number of hands that you can come up with, where order does not matter. This is better if you guys all come over here.
Thank you so much.
Would you mind moving? All right. So what happens is, if you take a deck of cards, you have 52 of them. Okay. When I'm just shuffling them out, it really didn't matter for the order that just got placed out here. What happened is they just got 5 cards. It just got dealt to you. When you take your 5 cards, it doesn't matter where they were because more often than not, you're going to start rearranging them depending upon the game that you're playing. Ooh, I'm looking good today.
What are you playing? What's his card?
Oh, it's one card away from
So-
wow.
Three of a kind.
So what happens is when you are when you're playing just regular 5-card poker, and this is a lot of the stuff that we deal with in this class are going to be poker hands, 5-card stuff, because it's a very easy thing to work with. It's visible. You can work through it. When your order doesn't matter how things get shuffled out, we try to figure out how many different card hands are there possible.
Well, what's blind?
We don't do that. I'm just doing the normal here. So what you're doing here is, because now what you've just done is you've taken 52 cards, and you say, what's the probability of picking the one card you want? What's the probability of the next one you want? What's the probability of the next one? Then
So
you have
out
to.
of all the cards you can
No,
get.
no, 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 no. You're doing something different. I'll talk about that later. We're not there yet. No. So the number of hands that you wind up is you're looking at what's called a combination. Combination.
Fancy.
I am nothing but fancy. I exude elegance.
He's like,
Exude. I don't know.
I don't think that's the word you were looking for.
It's not the right word, but I sold it. So you guys, remember, it's
Like-
not what you say,
That's
it's
like-
how you say it.
I use my card to
Hey, bring it-
I'm raising it up.
Yeah, bring it out of the grave. There you go.
That wasn't nice.
But I said it in a nice way.
All right, screw you. All right. So what we're doing here is called a combination. Now, you guys saw the button on your calculator, we had the NPR. This is the NCR version. I know.
It's the math probability.
So you guys don't have to move too far here. Let me just do this. What happens here is we're doing the combination. Combinations are for when order does not matter.
What does it?
Wombo combo. That ain't Falco.
Sam, I wasn't asked.
So this is called a combination. That's when you use that one. This actually simplifies out to be n factorial over n minus r, quantity factorial, r factorial. In other words, there's a button on your calculator to do this. So you have your calculator out. We're looking at possible 5-card hands. There are 52 cards. We're going to choose 5 of them.
Why do you want to choose that?
Because I'm doing 5-card hand. Okay. How many are there?
Put it in. Put it in. You're the calculator guy.
Math.
The same thing.
You gotta put the number in first, Chris.
Oh, you don't.
We do.
259.
2,598,960.
2,598,000. So this is basically, this tells me that in a hand of, in 5, man, please sit again. Thank you. In 5-card draw, 5-card deal, if you will, there are basically 2.6 million different combinations of cards being put out there. So that's one combination. Oh, that was looking good. That's another combination, and so on and so forth, where these things just get going through. Now, think about, you guys know the rules at all of poker?
Yeah.
Okay, what's the greatest hand you can get?
Royal flush.
Royal flush. A royal flush is when you have ace, king, queen, jack, 10 of all the same suits, okay? The way that poker works, we're going to start talking about how you can win and how things look, and when we start getting more into the probability. The lowest hand in poker is just high card. If you have no pairs, nothing of a kind, no same suits, no string of consecutive numbers, all 5 of them being in a row, it's like, oh, I got a king. Good luck on winning that hand, but sometimes it works. So then after that you have pair, and then it's 2 pair, 3 of a kind, straight, and then full house, flush, or it's 4 of a kind, then flush. I think, whatever, there's a bunch of different little ones that are thrown in there, but the most the one that doesn't show up very often is called the royal flush. The way that a royal flush works is that you only have, well, how many suits are there? 4. If you have one suit and you want to get all 5 of those cards, there's really only 4 different ways this is going to work. So out of that 2.6 million possible card hands, there's only 4 that are a royal flush. So if you ever get a royal flush, go play the lottery and bet everything that you have, because no one's going to beat you. No, I'm serious, because no one's going to beat you. Because the possibility that somebody else has a royal flush at the same time as you have a royal flush, it's not going to happen.
But if you both have one, then what happens?
So that's why you lost.
Then it's like,
Oh, yeah.
Nobody wins.
Mr. Murphy,
Well,
that's why
then
you
they're
lost.
not hired.
Yeah, you bluff it, right?
Mr. Murphy, it's
There's
high
no-
card.
Yeah. What's
Well, no, I mean, you don't want to just go all in.
Well, high
I mean,
cards,
there's
your royal
still-
flush is royal. It's
Still
they're all the
both
same
right.
because it's ace.
But
It's
then if
ace.
you're playing with suit,
Hey, I don't know if people do that.
not with high
So now, what happens with this is that when you're dealing with just straight, when you're dealing with like 5-card draw stuff, you're looking at ways that things can be. How many different ways can things be drawn out? For example, if I wanted to take, let's see if we do. Well, you guys are close.
I'll bet you my lunch money.
I'll bet you a quesadilla.
Yeah, I'll bet you my finger.
I've got a quesadilla.
Can I bet on something?
I had one earlier today.
Oh, yeah.
What a good poker face.
Yeah.
Because you
Oh,
I
know,
can
no.
have absolutely nothing.
Thank you, it's actually kind of good. I don't know.
So what happens here is that what you're doing in your mind as you start thinking about, there are, like I said, there's basically 2.6 million different possibilities here. When you have a pair, or if you have 2 pairs, the more of the same style cards you have, the better off you're going to be. The more of the if you have if you have the same, you guys going to make a pyramid or something? The more, if you have the same suits, if you have the same string of numbers, you're going to be better off because it's going to be more difficult to get consecutive values. That's where they start wagering through. That's where, if you're playing, you start to learn how to wager better. I'm just saying this for informational techniques. I'm not saying to teach.
Teach us poker.
So, what did you get?
Wouldn't that be cheating? 7 of diamonds, ace of clubs,
His label.
You don't need to go.
So, what you're saying here, what'd you get?
Does mine look awesome? I don't know how to play poker. Is
Oh,
that
that's
good?
pretty good.
That's one way
It's
to
nothing.
flush.
If you were to set
But it's not fair.
Now, in draw, what you would have done here is you would have discarded something. What would you have gotten rid of?
Let's do.
You get more. You can, actually, if you have an ace, you can get rid of 4 cards because you have nothing. Yeah, I would just get rid of all 4 cards and keep the ace.
Do I do the same thing?
Well, I will show you. So you would get 4 cards.
show?
Sure. See how you did.
Oh, that's good.
So in your
Wow,
case,
loyal.
what you would be doing here, since you have a 9, 8, 10 of a hearts, and you have all 4 hearts, this is pretty sweet.
So do
Because
I
if
get rid
get-
of this
if
and
you
try to get a 7 of hearts?
Or that would be kick ass if this is a 7 of hearts, because that would be really, really cool. I don't know if it's going to happen, but straight flush on your first try. Don't keep going. Just stop. Don't ever do this again. All right, so you want to get rid of that?
Yeah,
Never
because what
stop.
the hell?
You got a pair of 8s.
Uh,
All right, now you got a whole. I would get rid of those 2 because you got the diamonds and maybe hopefully hope for the best.
Do you like to live dangerous?
5.
nice.
You're showing 6.
So me, I would probably sit here and just say I got a pair of 6s and just hope for the best. Yeah, 6, 6, 6, and I got nothing.
Christina, you
That's what you. That's how you start to play through with poker.
I have no
Okay.
idea.
What are we betting
Sucks.
now?
Hold'em is the same basic idea, but with Hold'em, you only have 2 cards to start with, and you're playing against a community 5 card. So it basically, Hold'em is 7 card, and you're picking the 5 best out of them.
Why did
You all right there?
Why did you do that?
I'll stick to solitaire.
Now,
Yeah, spider solitaire.
the other thing you want to look at.
Right.
Sorry. I got Mastermind. You ever play that?
Yes.
Mastermind is awesome.
Go with that. Is Mastermind the one with you have to guess the colors? And
Yeah. So here's what happens with this. If you start doing it, just flip them over, I'll show you what happens. So what happens in this game is the same basic principle. You burn one, you flip one, burn one, and you flip one. So what everybody's doing here is we're taking the 2 cards that we have and we're matching them up against the cards that are here in the deck. Right about now, I'm kicking some major butt. So are you. Because take a look at this. What does he have? He's got a flush. So right now, you, holy crap, look at this. You also have the flush.
Yes, I have.
So, and I have the flush. So, at this point in time, I'd be thinking, holy crap, I got a flush? This is awesome. And I'd start wagering, and he'd be like, oh, our call. He can't have anything that beats me. And she's sitting here, what's the word in Russian for food?
Kaka.
Holy caca! It's like a bird. Caca! And he's getting bird's poop.
Yeah. Because of that, living things which don't.
Bird poops are mine now. My initials.
Don't knock it, I'm working on it.
My initials.
So, what I'm seeing here is that she'd be sitting there in the corner, just, okay, calling everybody's bets, and at the very end she'd probably put in a little extra more because she has all of this as a flush, but she has the high card. Holy moly! Okay, so this is what we start looking at when we start playing games like this. Well, if all three of us are playing the same hand here, basically, if high card wins. Now, if this wound up because you had a 6-5, 9-8, 6-5, 3. I mean, if this was, like a 7 or something, we would get a straight flush. Sweet. But so that's how poker hands look. What do we got time? The difference between this versus
We got 20 minutes.
we got plenty of time.
Whoa, what?
My non is like having so much fun. You guys
What is the probability in what?
Sam goes, they have an attention span of a bee.
I wouldn't give him that much. I go with a nap. Look at
You're better than your brother.
Aw, that works.
Oh, did you just hear me say no?
Shot fired.
Oh my God, wrong.
Have you never done this?
Let's do the odds of
You should
nine.
start doing
I got
this.
you.
Yeah, that's super awesome.
That's like, you know the game on Facebook where you have to like make as many baskets as you can?
That game.
It's like that.
Did you never think of this?
Yeah, you should totally do that with the other math teachers.
Did you ever think of this?
Honestly, think I never thought of that.
Yeah.
Yeah.
Wait, what happened?
You ungrouped it by mistake.
GG. It's game over.
Select it all and then group it.
Now,
He somehow grouped it.
Sorry.
can I help you?
I can, you know.
Nice.
So the other thing that we look at here, hold on, let's do a couple, and then I'll show you blackjack.
Oh,
Can we play blackjack?
I love blackjack.
That game is so much fun.
Oh, I kill the blackjack. Anti-school.
Yeah, we'll go back. I got a couple other
Why? I thought of that. That was fun.
Wait, can you go back? Sit back here.
For what?
Eric, you want to face
All the NCRs for order doesn't matter. That's basically it.
And how many?
So when we're dealing with these, when we're dealing with this combination is when order doesn't matter. So it's number of pieces, how many you're picking. When order doesn't matter. 52 cards, choose 5. 52 cards, choose 2. That's like a blackjack idea. How many different ways can you arrange 2 cards out of 52? Yes, sir.
Well, we have to know like card games, like knowledge of those games.
what I'm trying to get this down to, it's not that it would be the knowledge of a poker game. It would be, the next question that come up here is, how many different ways can you get all 5 cards the same? How many different ways can you get 3 of one and 2 of another? It doesn't matter about the knowledge of this, it's just the knowledge of how many cards are in a deck and how the suits break down. That's basically the most basic, that's the most you need to know if you're not a card aficionado.
Wait, so the N and the R stand for the same thing?
Yeah, number and draws. So if I'm looking at the idea of in 5 cards, if I'm going to pull 5 cards, and I want to figure out a way that I can get all 5 of them being the same suit. So I want to get, like we did where we had the hold'em hands, where we all had the same suit. We had flushes. Can't believe we had 3 of them out of 4 hands. That's nuts that happened. It doesn't happen. What's that? Not very strong at all.
We can turn this into that movie where all the kids in the college class go to Vegas.
Oh, the Northwestern?
Yeah.
No. Road trip. When you deal with this, we start looking at more of almost a combination. I don't want to use the word combination, but we're going to put more of these probabilities together. But we're not finding the true probability yet. We're just counting. I'll throw the probability part in here in a second. So if you want to get of all the hands, what do we have? it was 2, 5, 9, 5, 9, 8, 600?
8, 9, 6, 0.
8, 9, wait.
No, it
8,
was
9,
5, 9, 8,
9, 8, 9, 6, 0.
2, 5, 9, 8, 6.
9, 6, 0.
Okay, I was close with that. So that's the total number of different card hands you can get when you're drawing 5 cards. Now, of these roughly 2.6 million hands, how many of them will be of the same suit? So what you have to do is start thinking about, well, how do I select a suit? Well, how many suits are there? 4 of them. So there's 4 suits. I need to select 1 of them. Now, of that suit, how many of those cards do I need? 5 of them. How many cards are in that one suit? So it'll be a third. Now I'm down to 13. Get 5 of them. So you start to piece them together a little bit more. So you start looking at, well, I have 4 suits. Pick 1. Of that suit, I need 5 of the same. So I do the NCR twice, and I multiply them together. If I believe 4 choose 1 is still 4, right? And this is going to be 13 over 8 and the 5, so this is so 99 times 13. $1,287. So there's 1,287 different ways of picking out.
I'm getting deja vu.
Yeah.
Oh, then multiply that by 4, and it'll give you 5,000.
148.
So of the 2.6 million, 5,000 of those hands are pretty good. But when you look at it percentage-wise, what's the probability of that actually occurring? Remember how you do favorable? When you do probability, you take favorable over total. So this would be 5, 148. What was it, Rex?
0.0019.
So basically, it's a 0.19% of that even occurring.
So you're telling me there's a chance.
And this is kind of goes back to the idea yesterday when we were talking about the number of ways we can just arrange our sequence chart. When you start to think about the enormity of numbers, how big numbers really are. Yes, sir.
Is this part of counting cards?
Kind of. It's a little bit.
Let me try it.
I'll show you. Now, what happens when you start thinking about when you actually, you can say 3.6 or 2.6 million all day long, but how long would it take you to count to 2.6 million? It's if you said all those numbers in 1 second. So 2,500,980 or 2,598,960, 2,598,959, 2 million, and so on. That takes a lot longer to say than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you just let's just say you average it out, and it does over a long haul. Let's say it takes 5 seconds to reach every number. Okay. So if I have to take 5 seconds to say each and every one of these, how many total seconds would I have to use? 5 times that. So what's 5 times 2.1?
It'll slowly take less time.
So then there's your seconds. Then divide that by 60. Divide that. So what are you getting? About 150 days of non-stop counting. No eating, no sleep. So just instead of being 150 days, let's just say you do that for 8 hours a day. That's your job. I mean, so it's gonna take you a better part of a year, just all for 8 hours a day, all day, to count to 2.6 million. Yes, sir.
And then if you forget,
But the longest number ever counted to was 1 million, and it took him 3 months to get there.
Wow.
For charity.
That's
All of it. Yeah, all of it is available on the internet.
That's really cool. It's like the guy, remember I showed you guy that did the pi to 20,000 digits, and it still took him what, 8 hours to do that?
Yeah.
So that's nuts. So when you start thinking about the enormity of numbers, it just gets to be crazy. I think, you want to learn about blackjack?
Yeah. Yes.
Yeah.